This is 8th session on ionic equilibria. In this session, we will be dealing with the hydrolysis of salts. And this is a big topic which will be continued in the next session too. So, let us see what do you mean by hydrolysis of salts, and there are types of salts, and depending on that the hydrolysis differs. So, let us see what are first we will see what are salts. Salts are those which are formed from the neutralization of an acid with a base. So, acid and base react to form a salt. So, that is salt, and salts, since acids and bases differ in their strength and all those things, there are different types of salts. There are salts formed from strong acid and strong base. That is one category. Okay. Then second one is from weak acid and strong base. Third one, we can use a strong acid and weak base. Now, fourth category is both acid and base are weak. So, you have 4 types of salts where both acid and bases are strong, they react to give a set of salts. When acid is weak while base is strong, you get another type of salts. When acid is strong and base is weak, you get another type of salts, and when both are weak, we will get another different type of salts. So, we are going to see in detail what is the effect of hydrolysis on all the 4 types of salts. So, first we will see what do you mean by hydrolysis of a salt. Hydrolysis of a salt means it is an interaction of cation or anion or both with water, or if you are taking some other solvent, it can be with that, and usually the word hydrolysis is used when water is used. So, the interaction of water with the cation or anion or both cation and anion is known as hydrolysis of a salt. It does not involve any hydration, it is interaction between the ions with water. Okay. So, do not confuse it with hydration, that is something different. Okay. When it is for a salt, it is known as salt hydrolysis or hydrolysis of a salt. Now, we have, I told you, you have different type of salt. So, we will see what is the hydrolytic effect on each type of salts. So, first category I am going to take is a salt from strong acid and strong base. You can take any salt, that is, it should be from strong acid and strong base. Let me take an acid HCl with a strong base KOH, you will get KCl and water. So, this is a salt where acid is also strong and base is also strong. It can be instead of KOH I can take sodium hydroxide, instead of HCl I can take HNO3 plus let me take NaOH, you will have sodium nitrate and water. All these belong to, you can take sulfuric acid, all these belong to the category of strong acid and strong bases. Now, what happens here? Here, let me take an example of, let it be sodium chloride. Sodium chloride when put in water, it ionizes as Na plus Cl minus. Since these ions are from strong acid and base, they are very good ions. They do not interact with, they are almost stable and they do not want to interact with water to release any other product. Instead, they may get hydrated. Hydration is possible. Hydration means it is just the ion being surrounded by water molecules. There is no chemical interaction between them. Chloride ion also, it gets surrounded, it can get hydrated, but it never gets hydrolyzed. So, any salt formed from strong acids and strong bases, they do not undergo hydrolysis. So, they do not have hydrolysis. So, you can exclude these type of salts, they do not hydrolyze. Now, let us see salts of weak acid and strong base, how do they undergo hydrolysis? Now, we know that we have the acid to be weak. So, let us take an example as acetic acid. Okay. Now, we have to take a strong base, let that be NaOH. You can also take potassium hydroxide or whatever you like. Now, when these two react, the salt form will be CH3COONA plus H2O. Okay. So, this is CH3COONA, which is known as sodium acetate. Now, this sodium acetate is a salt which is formed from a weak acid and a strong base. Now, sodium ion comes from strong base, it will not undergo any hydrolysis, but the acetate part which comes from a weak acid will interact with water undergoing hydrolysis. Let us see how it is. That is the acetate ion minus, and that is derived from the ionization of that weak salt from weak acid and a strong base, CH3COO, which is the anion, and Na plus is the cation. This is from a strong base. Now, acetate ion being weak, it interacts with water, and what happens is water protonates acetate ion, giving back acetic acid CH3COOH, and you will have, once the water has lost its proton, it changes to OH minus. So, when we add sodium acetate to water, what happens is there will be an increase in concentration of OH minus ions. What will happen? The resulting solution will be basic, or you can call it as an alkaline solution. So, when we hydrolyze a salt of weak acid and a strong base, because the base is strong, of course, the resulting solution will be alkaline in nature. Now, let us see an expression for hydrolysis constant of this salt derived from weak acid and a strong base. So, this is a salt which will be completely ionized. Okay. It interacts with water to form HA and the alkali BOH. HA stands for weak acid, okay. Since that is weak, it does not get ionized, but alkali being strong, it is completely ionized. So, I have written it like that. Now, cancelling the common ions, one is, I take another color, that is, this is B plus, and here also we have B plus. They both are of the same ion. So, what I am going to do is, I am going to remove, because that is on the both sides. So, finally, we will have the expression as A minus plus H2O giving HA plus OH minus. Now, I am going to write down the equilibrium constant, and this is actually for this hydrolysis reaction. So, I am putting it as K is equal to concentration of HA into concentration of OH minus whole divided by concentration of A minus into concentration of H2O. Okay. Now, since water is present in excess, that can be taken as a constant. So, I am going to take this here H into concentration of H2O is equal to concentration of HA into concentration of OH minus whole divided by concentration of A minus, and this factor is considered as the hydrolysis constant Kh. So, I can write this expression as Kh is equal to concentration of Ha into concentration of OH minus whole divided by concentration of A minus. So, let this remain here. Now, since it forms a weak acid Ha, this acid can interact with water and you can write it as H3O plus A minus. Should remember, this is a salt formed from weak acid and a strong base. In that case, I will first derive the value for Kh, then I have to go for another dissociation constant that we have to check it like this, like whatever is weaker. In this case, acid is weak. So, I am going to give an expression for ionization constant of a weak acid. So, from this again I am going to write an expression for dissociation constant or ionization constant of a weak acid. Here water is eliminated because that is present in excess, and the expression will be H3O plus into concentration of A minus whole divided by concentration of Ha. We know another factor, that is ionic product of water Kw is equal to concentration of H3O plus into concentration of OH minus. Okay. Now, what we are going to do is, we want an expression of Kh in terms of dissociation constant of a weak acid. That is what we are going to do, and here you just watch that what happens when I divide Kw by Ka. Kw is H3O plus into OH minus divided by Ka. What is Ka? We have H3O plus into concentration of A minus in divided by Ha goes to the numerator. So, I will put it as Ha. Okay. Now, cancelling the common terms, both get cancelled and you get the expression as HA, concentration of HA into concentration of OH minus whole divided by concentration of A minus. Just compare these two. These two are same. What does it mean? KH is equal to KW by Ka. That is the expression for hydrolysis constant. So, hydrolysis constant of a salt which has got a weak acid and a strong base. In that case, hydrolysis constant will be ionic product of water divided by dissociation constant of a weak acid. So, we can guess what will be the hydrolysis constant for a salt in which the acid is strong and base is weak. It will be like this, that KH will be equal to KW by KB, where B is the dissociation constant of the base, which we will see later whether it is true or not. Next, we have to find out the degree of hydrolysis. Okay. Again, we are going to take this expression where A minus plus H2O gives HA plus OH minus. Here, degree of hydrolysis means it is the fraction of the salt that has undergone hydrolysis. Just like degree of dissociation, it is a fraction of the salt which has undergone dissociation, and if it is ionization, it is a fraction of the salt which has undergone ionization, and degree of hydrolysis is fraction of the salt that has undergone hydrolysis. And this degree of hydrolysis, usually it is represented by the small letter x. Alpha is given for degree of ionization or dissociation, and x is used for degree of hydrolysis. Now, here just like we have been doing so far, the initial concentration, let that be C moles per liter, and initially these two will not be formed, and therefore, that is 0. When equilibrium is reached and we consider x to be the degree of hydrolysis, it comes C into 1 minus x, and in this case that will be Cx and Cx. Now, we are going to apply that to the equilibrium expression KH is equal to concentration of HA into concentration of OH minus whole divided by concentration of A minus. Substituting the equilibrium concentrations, we will be getting it as Cx into Cx whole divided by C into 1 minus x. C and C get cancelled, and that becomes Cx square by 1 minus x. Assuming the degree of hydrolysis, the value of x to be very small, which we have been doing so far, you can put 1 minus x is equal to 1, and therefore, KH is equal to C x square, and the degree of hydrolysis x is equal to, you take it over here, it becomes KH by C, and it is the square, and if you take the square root, that will be the degree of hydrolysis x. But again, you can substitute KH. We know that this is a salt formed from a weak acid and a strong base, and KH for that is given by the expression KH will be KW by Ka, and we have a C over here. So, this is the expression for degree of hydrolysis in which the acid is weak and base is strong. Next is we have to find out the expression for pH. Now, here we have taken a salt which is formed from a weak acid and a strong base, and we have written down the ionization in that process and an expression for hydrolysis constant. Now, we are going to find out an expression for pH. Here the expression goes like this: A minus plus H2O giving HA plus OH minus, and the concentration at equilibrium condition will be C into 1 minus X of A minus and Cx both for HA and OH minus. Now, to find pH, you are supposed to find out first pOH, because once we get pOH, you can find out pH by subtracting pOH from 14. Okay. So, to find pOH, we require the concentration of OH minus ions, and from that you can see that is equal to C into X, where X is the degree of hydrolysis. The degree of hydrolysis is written as square root of Kw divided by C into Ka. Now, multiplied by C, the C is there. This C and this C gets cancelled, because this is root C and this is C. So, it becomes root C times, and that is equal to C into Kw by Ka, root of, and taking negative logarithms, I can put this as pOH, that is negative logarithm of OH minus, is equal to negative logarithm of, putting it the whole thing in the bracket, because it comes under the square root of Kw into C divided by Ka. Okay. Now, I am going to expand it. Logarithm, this is root, and that can be written as minus of log Kw into C by Ka whole raised to half, that stands for the square root. Now, this is a power for log. So, I can expand it as minus of half log Kw, again minus of half log C, and this comes in the denominator. So, that becomes minus of minus plus half log Ka. Next, what we are going to do is, we are going to find out the pH, and therefore, I have to subtract this value from 14. pH is equal to 14 minus the whole thing in the bracket minus half log Kw minus half log C plus half log Ka. Okay. Now, here this is 14 itself. I am taking minus of log Ka, that is this minus plus log Kw. I am going to write it as Pkw. Then here that remains as such, that will be minus of half log C, and here we do not have a minus. So, if I have to take negative, this should be two negatives minus of minus. So, this minus and log Ka becomes Pk. So, minus half Pka. pKw means that is equal to 14, half is missing, is equal to 14. So, again 14 minus bracket half into 14 minus half log C minus half pKa. Now, again half of 14 means there is 7. I am going to expand the expression 14 minus 7. This minus and minus, this becomes positive half log C. This minus and this minus, again it becomes positive plus half pKa. 14 minus 7, that is equal to 7. 7 plus, I am going to take both the half outside as a common factor into, I will write pKa first, pKa plus log C. Now, this is the expression for pH for a salt formed from a weak acid and a strong base, weak acid and a strong base. And this value pH depends upon dissociation constant of the acid as well as C, that is the concentration of the salting. With this we conclude. In this session, we have been seeing hydrolysis of salts, and for salts formed from strong acid and a strong base, there is no hydrolysis taking place, only hydration of the ions takes place. While when we have salts of weak acids and strong bases, that will be the case when we have some of the ions, that is usually that ions coming from the weak acid interacts with water, forming a particular type of ion, usually that releases OH minus ions, and the solution becomes alkaline. And we have been deriving the equation for pH also. Thank you.